question is, were people interested in going over the answers to the quiz from last week? Is anybody interested in sort of seeing? I know several people did quite well. Some people were kind of confused. I'm happy to go through the answers if anybody would like to. That's kind of why we have this. So you would like
number to.
2. Number 2? Is that, did I see a second for number 2? Question 2? Everybody wants the question 2? Okay. Question 1, I think, was just like what we did in section last time. So it should be clear by now at least. So question 2, here's the question that I asked, which was, I said that clock and second chance FIFO are approximations of LRU, meaning that they don't actually evict the least recently used page. And the question asks, explain why does it make different decisions than LRU? Yes?
Sorry, can I add something about question 1?
Sure.
Were the page frame numbers valid for this mapping?
Were they what?
Were the page frame numbers within the valid range of the number of?
So what happened was the copy that I gave to most people said 2 megabytes for physical memory size instead of 128 megabytes, which it should have said. And so I directed the TA to accept either saying that these were invalid because the page frame numbers were invalid, or to treat the page frame numbers as valid, which was my fault for writing the question poorly. But ideally you would have treated these all the ones with the 8 here set as valid PPEs. And it was just my cut and paste error to not have set the physical memory size correct. Okay, so back to the other question. How do they make different choices? Pardon me. I'm still working on this nasty talk. So since you're all very familiar with second chance FIFO, I think I'll explain it in the context of clock, just so you learn more about clock. To be honest, clock is probably more well known than second chance FIFO because it's used in Linux and Unix-based operating systems. But it's a little bit more of a hassle to implement in this project. So remember, the way clock works is we have our page numbers, and then we have a hand that sweeps around, and it checks if the reference bit is 0, it evicts it. If the reference bit is 1, then it will set the reference bit to 0. So the thing to think about is, suppose you have 2 pages here where you reference this page here, and then you reference that page there. So we reference, so B is the, actually we're going to reference in the other order. We're going to reference A, page 1 first, and then page 2. And the question is, what will clock do? What order will clock evict these pages in? So what happens is clock will swing around here. It'll get to these. It'll say, oh, these were referenced. We'll set reference equals 0. And then it will kind of swing around, scanning everything, come back again. And when it gets to this page again, it will evict it. Actually, I did this backwards. Sorry about that. So when it gets to this page again, it'll say, oh, the reference bit is set to 0, so I'm going to evict this page now. And the fact is, it doesn't know that this page, this next page here, has actually been referenced even less recently than this one has. So the core difference is that LRU has precise information on exactly when things were referenced. But clock, all clock knows is that since it basically knows about references during a scan interval, but it doesn't know the order of references in a scan interval. So it knows that as it swept around, the 0 time that A and B were both referenced, but not the order in which they're referenced. So it sort of takes the history of recency and it sort of chunks it into segments and says everything that wasn't referenced since the last scan is all equally old as far as it's concerned. And then in terms of ordering, instead of turning things in sort of true least recently used, it actually evicts things that are old, ordered by physical frame number. So that's the difference, that it has sort of very imprecise information about recency, and it evicts things by physical address, not by how old they are. So that's what makes it different. That's sort of where the inaccuracy comes from. So the second piece of the question was, how would you make it more accurate, more like LRU? And so the basic idea to make it more like LRU is you need more accurate information about how recently it was used. And so we talked about this in class, how you could do it. For example, you could actually keep sort of a vector for each of these that tracks when was it referenced. So what we can do is we can have a thread that just sits here and continuously scans pages in memory and clears the reference bit. And every time it goes around, it can sort of update what it finds here. And so this will give us, the more frequently we scan a page, the more accurate the information is and when it was last referenced. And so we can say, well, this was referenced 4 scans ago, but this was referenced 2 scans ago. So this page is closer to least recently used as compared to this page. And so that's how you would get more accurate information, is to basically scan it more often. Does that answer, explain a possible answer to that question? So the key thing you need to recognize here is you need to get, instead of just a was it referenced or not, you need to have some history of how much it was referenced, or how long ago it was referenced, which means you might have to sample it multiple times. In a second chance FIFO, you might have multiple, instead of just a first chance list and a second chance list, you could implement this by having multiple, like 3 or 4 or 5 lists, to keep track of how long has it really been since it was referenced. And then, you know, the things on the 5th list are the really old things, the 4th list are the kind of old things, the 3rd list are the somewhat old things, to keep this kind of information. Okay, does that answer people's questions? Okay, any other questions on the quiz? Yes?
Oh, can you explain for part A, when you have second chance FIFO, like where exactly it differs?
Okay, so if we have second chance FIFO, we have sort of a first chance and then a second chance. A second chance list. So in second chance FIFO, what happens is we sort of put the pages in this in the order in which they're first referenced. So if we reference page 1 and then page 2, we put them in the first chance list in this order. Suppose we then never reference page 2 again, but we keep on referencing this lots and lots of times. And then when they get bounced out of here into the second chance list, we never reference them again. So down here we'll have them in the same order. So what happened is we'll now evict page 1 even though we referenced it more recently than page 2. So the problem with second chance FIFO is that when something is in this first list, we don't know when it was referenced. We think we basically say that every page was referenced continuously while it's in the first list, or more or less. So if something was only referenced when it was first put in this list but not later, we don't really know about it. And so that's why second chance FIFO is inaccurate. Because again, this window is all treated as equally old. Does that make sense? Yes, Kaushik.
Would you have a longer second list to mimic LRU?
Yes, so you could. So you could definitely, if you went something like this and made this a lot bigger, then you would get LRU because every time something's in the second chance list and you reference it, you move it back to the head of the first chance list. You end up with really, really terrible performance though, because what's happening is that you're basically taking a soft page fault on most of your references now to keep track of this recency information. But that would have been a fine answer, is make your second chance list really long. It's a good point. Okay. So let's see what else I have up. So copy on write, I think, is probably fairly clear from the lecture notes.